Now that we've got the Maqueen assembled, let's have a look at some of its programming capabilities. And the easiest way to go about programming the microbit Maqueen is to use MakeCode. So this is an online editor that allows you to program the microbit device using JavaScript or a graphical block language, as I'll show you. Before I go any further, I just want to mention two things. This video is not a tutorial on how to use MakeBlock, even though I will say a few things about it just so that you can follow along what I'm doing with these simple examples that I'm about to show you. The second thing is just to highlight the fact that I am programming the microbit using the Chrome browser, and there is a nice feature here that allows you to upload programs to the microbit directly from the browser without having first to download a program to your computer and then to copy it across to the microbit special folder. So if you want to know how to do that, just go to support.microbit.org and search for web USB troubleshooting, and down here you'll see instructions on how to set up your Chrome browser so that you can upload files and programs directly to the microbit. This is the method that I'll be using. As I said, it saves us the trouble of having to manually copy a hex file for the microbit program to the microbit. Now the second thing that I want to mention is that everything that I'm going to show you is part of the DF robot documentation for the Maqueen. So you can find it by going to the DF robot micro Maqueen Lite product page and then scroll down here, and you'll see a bunch of links. Getting to that now. Almost there, almost there. Almost there. There you go, documents. There's a product wiki and lots of tutorial PDF files, such as this one right here. Great for a classroom. Nice instructions on how to get going with the microbit and basically learning how to program in block language. And here's the wiki page as well. Everything that I'll show you next comes from this wiki page. All right, so let's do something simple. Just going to close this window. Let's say that you'd like to do something extremely simple, such as doing a little bit of programming. In this case, motor control. So our Maqueen contains two motors. Let's learn how to use them. And I'm going to skip all of those details and go straight to the program, show you how to get that going. And the program itself is almost self-explanatory. I will make a few comments. So right click on this link, go to new tab, and here is the program. Now the program comes in two forms that are interchangeable. There's JavaScript and there's the blocks. Probably when you are just starting up with programming, the blocks language looks easier to begin with, and then later on when you start getting a sense of the programming language, you can switch to JavaScript, which is more explicit. As you can see here, it's more like a real programming language. So back into blocks, you'll see that we've got a outer instruction called forever, and whatever you put inside this instruction, the forever instruction will keep repeat itself exactly as it says forever. Inside the forever block, you'll see green instructions called motor. So this is the name of this instruction with a few parameters. So this means move all the motors forward at this particular speed. Then we've got a blue instruction called pause, which means that the Maqueen will not do anything else until, in this case, 1000 milliseconds or 1 second elapses. And then the Maqueen is going to execute these next two instructions, where the left motor is going to continue going forward at this speed, where the right motor is going to stop, essentially 0. And then you follow the exact same instructions, but with different parameters. So let's try this out. The easiest way to actually play with this code, there's a few different ways, but I'll show you one that I like. I highlight the JavaScript version of the code and do a copy. Then you can go to the editor at makecode.microbit.org and start a new project. let's call it Maqueen motor example 2, because I already have the first example. Now here, again, switch into the JavaScript version of the code, delete the content, and then select paste. Allow the paste, and now you've got the same code as from the example in your own editor. Notice that there is a red line underlying the words Maqueen, or these are instructions. Anywhere there's Maqueen, there's an underline, a red underline. That means that the editor right now does not know what Maqueen is. And that's because we have not imported the necessary extension to the editor. So to do that, let's go to the extensions button up here in the search bar, search for Maqueen and hit enter. And then you'll see the Maqueen extension in the box right here. So click on it to import it. And now you've got a new set of instructions here called Maqueen. All these instructions are relating to the hardware that comes with the Maqueen car or the board. We'll be able to use those to do things that are on the, we'll be able to use those instructions to control the hardware that is on the Maqueen motherboard. And after importing the Maqueen extension, you'll see that there is no more red underlying under the Maqueen instructions. So that means that we are now able to go into the blocks mode and have a look at the forever loop, actually, and have a look at the program in block language in our editor. And now you can actually interact with it. So you can see if you click on those parameters, you get options. So you can control left, right, or all options. You can go forward or backwards, and of course you can change the speed. And because the Maqueen right now is on my bench table, which is fairly small, and I want to make sure that it doesn't run off the table, I'm going to reduce the speed. So let's make that, I'm going to just type in here and type in 50. And make all the 255, I'll make it 50, just to reduce the speed so that my Maqueen does not fall off. I'm also going to reduce the pause here to just 200 milliseconds. So that's going to reduce the amount of time between the execution of those instructions. So the speed, maximum speed is now 50. It's going to go forward at 50, and it's going to turn left at speed 50. It's going to turn right at speed 50, and so on. And the pause between those speed changes and direction changes will be 200 milliseconds. Now let's go to upload this program. The first thing to do is to connect the device to my browser, and this is the process to follow. So I'll do that again. Cogwheel, connect device, next, next. Select the device from the menu. I've only got one, and then click connect. And now we are connected. So I'm going to click on the download button here, and you'll see that the just going to turn the Maqueen over. So notice this orange LED, how that is going to blink. Alright, so now I'm going to click on download. There's flashing activity, orange LED, and the program has downloaded. Now I'm going to unplug the USB cable, and there's a switch. There's a switch right here. I'm going to turn it on and see the Maqueen moving. There you go. So the motors are working. Great. Switch off the motor, switch off the Maqueen, I should say. I make sure that the switch is off, especially if what I'm about to upload control the motors. Alright, so connect USB. And let's have a look at another example. So that was a motors example. Another example, let's see how we can control the RGB LEDs. So at the bottom of the microbit Maqueen board, you'll see there's 1, 2, 3, 4 RGB LEDs. So let's see how we can control them. So for that, I am going to copy this program from the wiki. It's this program here. I use the same method as in the previous example. And to save us the trouble of copying across, I'm just going to go straight to the example that I was playing with earlier. So in the schematic here, you see that the RGB LED strip, which is a NeoPixel strip, is connected to the microbit via one of its edge connectors here. So we apply power, 3 volts and ground, and then you have another data pin connected via a jumper wire to this edge connector. In our case, we don't have to worry about this because the NeoPixels, there's 4 NeoPixels that are attached to the Maqueen board. So we don't have to worry about this schematic at all. The thing to remember though is that again, you need to import the Maqueen extension. And because we're using NeoPixels, you also need to import the NeoPixel extension that gives you these instructions here. So we are using these instructions in our little program. So in the beginning of the program, we've got the onStart blue instruction. We just set the strip to NeoPixels connected to P15. This is the pin on the Maqueen motherboard to which the NeoPixel data pin is connected to the microbit. So this is always standard when you're working with Maqueen. And we've got 4 RGB LEDs on the Maqueen, so we'll put number 4 in here. And then we use a forever loop. Just put it here so you can see it a little better. It extends to the bottom of the design space. We set each component of the RGB LED to 0, and then we repeat 255 times going through a variety of letters. So in this case, we use the R and B as variables, and then we change the color that is created on the RGB LED by simply changing the R, G, and B components. So the in this case, RGB, there should be a B here actually. Yep, RB. So in this case, we've got the R and the B changing, and the G stays the same. As you can see, stays always 0. Then down here, we change the G and the R, and the B stays the same. And then down here, we change the B and the G, and the R stays the same. And that creates like a color effect. All right, so let's connect the device, paired and connected. So let's upload the program to the Maqueen. Okay, done. So I'm going to leave the cable on. We don't have any movement. I'm going to turn on the car. You can see the light show created by the 4 RGB LEDs. There you go. Makes a nice effect on the table. So there are 2 more things that I want to show you here. Of course, there are many more examples in the DF robot documentation and in the wiki. The next thing that I want to show you is how to use the ultrasonic distance sensor. And then, as the last example, we'll go to the floor and play around with the line following sensors. There are 2 line following sensors on the car. We'll use them to get the car to follow a line. So let's try out the ultrasonic sensor. All right, so let's go back to the documentation, and somewhere here is another example right here that teaches how to use an ultrasonic sensor. It's a very simple program. let's have a look at it in a new tab. It looks like this. It basically repeats the same two instructions constantly. The first instruction is to read the ultrasonic sensor, that's a green instruction, then return a number in centimeters and store this number in a variable called u. That's all this red instruction does. And then in the next instruction, the blue instruction, we use the show number instruction to display whatever number we've got stored in the u variable in the display in the front of the microbit. So let's try that out. I have already made a copy of this program right here. You can see that I've imported the Maqueen extension, so we're good to go. So I'm just going to upload this program to the microbit. All right, so here's the Maqueen. Here's the microbit. It's using its display to show a number. I'm going to use this PCB as a target and see the number changing as the distance between the sensor and the target changes. Now we're at 5 centimeters, 4 centimeters, 5, 7, go closer, 3, 2. It's pretty nice. It works quite well. So that's an example of how you can use this onboard sensor to measure distance to an object in front of it. Now the last example that I want to show you for the purposes of this video is the line sensor capability. So the capability of the car to use its two line sensors to track a line. And there is a program here. There's also a way to calibrate it. I'm going to show you how to do that in a moment. So the example is right here. So here's the example. Let's take a closer look at it in the editor. Now I've made a modification to this program because it was just a little bit too fast for the small line that ships with the Maqueen, with the chips in the Maqueen box. I'll explain in a moment. So here's a program. Basically what it does is that forever it checks to see whether it checks for 3 conditions. The first condition is for the output of both left and right line tracking sensors to be 0, which means that both of them are following the line. The other condition is for one sensor to be 1 and the other one to be 0, which means that the car has shifted to the right side of the line and therefore it needs to change the configuration of its motors, run up the left motor and slow down the right motor. That would cause the car to turn left and get back on the line. And the last condition is the opposite. So the car is veering to the left and therefore we need to move the motors in the appropriate way to get the car to veer back to the right and go back on the line. Now you can see that the program here, the example program, uses speed 200 when it's on the line and 255 and 50 for the left and right motor, or the right and left motor when it's doing turns. But I experimented with these numbers and found that they were just too fast for the small circle that I'll be using for this test. So I've just slowed the car down by reducing the forward speed to 25 and then the turning speed to 100 for the fast motor and 15 for the slow motor. So for example, if I want the car to turn to the right, then I'm going to move the left motor at speed 100 and the right motor at speed 15. And that would actually work well. So you can experiment with different speeds for the motors depending on the size, complexity, and how tight the turns are and things of that sort for your car. So let's upload this program to the microbit. Done. And let's take it down to the floor where I have already taped in the circle pattern that came with the micro Maqueen. Okay, so I'm going to turn on the Maqueen. There you go. And it's following the line quite well. Now if you're having trouble with this experiment and your car and your Maqueen is unable to follow the line reliably, there may be a problem with the calibration of the line sensors. The line sensors come pre-calibrated from a factory, so it should actually just work, but you never know. So what you're going to need is the calibration printout that is on the opposite side of the line sample piece of paper. So just flip it over and you'll see that there are two areas for calibration. One is for the Maqueen Lite, which is the device that I'm using here, and the other one is Maqueen Plus. So you could use either one. First, turn on your Maqueen. I have already uploaded the line following example program, and the way to do this is, because the wheels are spinning, I'm just going to hold my Maqueen a little bit over the surface and make sure that the two sensors, this one and this one, are right over the black area. So then press the line key and hold it. This is the button right here. Press and hold until you see the blue LEDs blinking. Then let it go, and that's it. Calibration is complete. And now the calibration worked, because when the two sensors are over the black area, both of them are off. So the blue LEDs are off. When you go to a lightly colored area, so the white area, they're on, off, and you can have one on and one off, and then the other one on and the other off. And that's how calibration works for your line following sensors. We're done. Let's flip the sheet of paper over and just try it out. There you go. Let's go back. Works. So in conclusion, I'm really impressed with the Maqueen. It's a really nice robot, easy robot to put together. Its educational advantages are obvious here. The programming language that you use to program this device with the microbit is very easy to learn. It's probably, in my opinion, the ideal programming language for absolute beginners. In the classroom, at home schools, self-learners will have no trouble at all learning how to program robotics. This is essentially a small robot, a simple to use robot. It's got integrated sensors, it's got expandability, so you can connect other components to the microbit and to the Maqueen chassis, so you can extend it and learn a lot of robotics topics. The instructions that come with it, the educational material is top-notch. It's really the best out there. This is our big advantage for anything to do with education in the classroom or out of the classroom. The language itself, you can see, very extensive. And speaking of extensions, there's so many more capabilities that I've just barely scratched the surface here of things that you can do with microbit in general and with the Maqueen in particular.